All right, this is the last lesson of the unit, which means it's the last lesson of the year. Applications of sinusoidal functions. This is really very similar to what we've been doing. The only difference is you need to figure out some of the information first before you can come up with the answers to the question. Okay, so let's take a look at the first example. It says a mass is suspended on a spring, as you can see in the picture, and the mass is pulled down, so it's going to be pulled down 0.4 meters, and then it's released. And you can picture this being on a spring. It's going to bounce up and down like this. Okay? It says the following information is obtained. It takes 1.2 seconds for the mass to return to its lowest position. So if you pull it and release it, it'll go up and down in 1.2 seconds. Okay? So what would this look like on a graph? Well, you should see that the midline is going to be at 0.5, okay, because it says it's 0.5 up. And then what happens is it's pulled down 0.4. So this will be at 0.1. Okay, and then it goes all the way up and all the way down. Now, why don't I make the graph look like this? Why don't I go up and down like that? Because that's what the spring's going to do. It's going to go up and down in one spot. Okay, why am I not going just straight up and down? Okay, well, it's because you guys know that time keeps moving, right? So this is going to go up and down while time moves on. Okay, it's going to be 1.2 seconds for it to go to its highest point back to its lowest point. Okay, and what is its highest point? Well, if it goes up 0.4, this is going to be 0.9. Okay, because it says goes up and down 0.4. It says its highest is 0.9. Okay, so there's our what our graph would look like, but it doesn't ask for the graph. It says determine the equation. Well, to determine the equation, the best way to do this is to use the calculator to do that. But for the calculator, we need some points. So let's compare time and height. At 0, what is the time? It's 0.1. Do we know any other points? Well, I know that at 1.2 seconds, it's down to 0.1 again. Okay, and I also know that it goes up to 0.9. When is it at 0.9? Well, you should understand that sinusoidal graphs are perfectly symmetrical, so this is going to happen exactly in the middle. So I would divide that by 2, and at that point it's going to be 0.9. Okay, so I'm going to enter that into my calculator. So I'm just going to clear both my lists. So I'm going to go 0, 0.6, 1.2. Do you think this is going to be enough to make a sinusoidal equation? Well, that's what we're going to find out. 0.1, 0.9, 0.1. Okay, so let's go stat, calc. I want the sine rig. It says invalid dimension. Why was it invalid dimension? Okay, did I not have enough information here maybe? Well, let's see if that's the problem, if it's not enough information. Maybe what we need is we need to give it a little bit more. Okay? Can you figure out some more of these points? Okay, in fact, you could probably figure out these ones. Okay? So, how would I figure those out? Well, you know that since things are symmetrical, this will be exactly in the middle. So maybe I need to put 0.3 and 0.5 in here, and then 0.9 and 0.5 in here. Let's see if that's enough to make this work. And I don't have to put this in order, so I can put 0.3 once, and I can put 0.9, and then at 0.3 it was 0.5 and 0.5. Okay, now let's try. So now it seems to accept our answer. So let's see if this makes sense. Okay, determine the equation. Well, we're going to have y equals 0.4 sine. Okay, and then b is 15.7 x minus it'll be x plus 1.6, and then plus 0.5. Now a couple things match up real nicely. 0.5, that's our midline, that's good. 0.4, the amplitude, that's good. So we're going to say that looks like it's the right equation. Okay? Then it says, when will the mass be 0.75 meters above the table? Well, here's why we want this equation. Because let's go and put this on the y equals here. So let's clear this. Let's clear this. First, we'll paste this. Vars 5 equation, enter. There it is. And then I want another equation. I want to go, when is it 0.75? Let's go zoom 9. Uh-oh. Do you remember what's wrong here? Okay. What did the equation do that we don't like here? We didn't want it to wave twice like that. That's a perfect fit, but that's not the right data. Okay, so let's maybe take a look and see if we can fix this a little bit. Okay, the mistake was that when I didn't put the points in order, it gave me an equation that's actually wrong. Okay, so what I did is I rearranged the things in my calculator here, and now when I go to stat calc and I try to find the equation, it gives me this. Okay, this is the wrong equation. This shouldn't be 15.7, it should be 5.2. Okay, and then this is still 1.6, and that's still 0.5. So there was a mistake there because of the way the calculator read the data. I'm not sure why it did that. I'm not even sure if it'll do that all the time, but maybe we should make a little note here to put this in the correct order. Okay, so now when I graph, I get a much better line. So I've got those both pasted in there, and now I've got the line y equals 0.75, and I want to know where does that happen. So I go to intersect, and remember I got to tell it, look over here. So I'm going to scroll there. So enter, 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 and the first time y is 0.75 happens at 0.4289 seconds. And we'll say that's 0.4 seconds. Okay. All right. Another question, very similar question. London Eye is a giant Ferris wheel in London, England. It has a maximum height, so let's just draw a picture of a Ferris wheel here. Okay, it says maximum height is 135 meters. The minimum height goes down to 0 meters, so it's actually at ground level. Okay, and one complete rotation takes 30 minutes. Okay, so if we were to put that on a graph, the passengers get on at the bottom, so it starts here, it goes to its highest point, back down to its lowest point, and this takes 30 minutes. Okay, this is 135. So you already have the graph. Okay, if it wants us to model it, do a sinusoidal equation, let's come up with a table. Okay, so we have time, height, so we'll go 0. And remember, we should have, didn't like it when we just had 3 points, so let's pick 5 points again. Okay, so at 0, we have 0 height. If this is 15, this is 7.5, right? These are going to be exactly symmetrical. So at 7.5, it is half the way up to 135. What's half of 135? That's going to be 67.5. Then at 15, it goes up to 135. Then at 22.5, it's back down to 67.5. And then at 30, it's back down to 0. Okay? So, put this in your calculator, see how good you are at this, and then answer the questions. Okay? I'll just pause for a little bit. Okay, so there is our information. There is our equation. Okay, then it says how many minutes would the passenger be at least 100 meters. So remember how to do that. We've got to paste this in first. And then for my second equation, I want to go 100 meters. Okay, so let's see what this looks like. There is the graph of the Ferris wheel, and there is 100 meters. So kind of old news here. Got to do the same thing. Tell it where to look. I want to look right here. And then go enter, enter, enter. Okay, and when will it be 100 meters? At about 9.9 seconds. Or I guess that's minutes. Okay. How many minutes would a passenger... Oh, that's not what it asks. It says how many minutes would a passenger be at least 100 meters above the ground. So basically, we're being asked to say, here's 100 meters. How long is this? Okay, well that's not too hard. We now know at 9.9 minutes it's there. Let's figure out what the other one is. So let's go look over here. Press enter, enter, enter. And that's 20.1 minutes. So from between those two values is how long it's going to be above 100 meters. So if I go 20.1 take away 9.9, I end up with 10.2 minutes. It'll be above 100 meters. Okay, so that's how these questions work. I think I'm going to leave the next couple. You can try them for homework, and then maybe I will ask you to, we'll do them in class together. But I think we'll leave those. They're pretty straightforward after this. Okay, so you can do those two questions, number 3 and number 4, and then there's the homework. All right.